Welcome back to this segment. As usual, my name is Samuel Chukwuemeka. In this segment, we shall be talking about literal equations. Literal equations. This is the kind of equation whereby you solve for a specific variable. You have an equation that has two or more variables, and you solve for a specific variables. You solve for a specific variable. Now, the literal equation can also contain constant. Yeah, but you have two or more variables. That is something that is particular about it. You will have two or more variables and constants, or you may not have constant, and you will be asked to solve for a specific variable. So we shall look at some examples. Example 1, we have that volume is the length times width times height. Now, you're familiar with this formula, the volume of a rectangle. Of course, you have it this way, length, width, height. So, but this tells you that this means length times width times height. That is what it tells you. And you want to solve it for the width, W, the width. So, what is on your left-hand side? That is V. What is on your right-hand side? You have the length, the width, and the height. When you are solving for a specific variable, you always want to make sure that what you are solving for is on the left-hand side. So we want to solve for W. We want to make sure that it is on the left-hand side. We don't want to leave it at the right-hand side. Why do we actually do this? Would you prefer to say P is equal to $5? Or would you prefer to say 5 is equal to $5 is equal to P? If you look at this, if you look at this example, when you go to the store, let's say you go to Walmart and you want to buy a pack of markers, and you ask the cashier, what is the price of this? Assuming you ask the cashier, assuming the price tag is no longer there. Then, will you prefer the cashier to tell you the price? Now, P is the price. Would you prefer the cashier to tell you, okay, the price is $5? Or would you prefer the cashier to say $5 is the price? Now, look at the way it rhymes. You would prefer the cashier to say, in a complete English sentence, that the price of the marker is $5. It usually flows that way. So we want to make sure that whatever variable that we are solving for, that it is on the left-hand side. That is what we want to always make sure. So in this case, the width, W, is on the right hand. So we can just rearrange. We can rearrange this. What do I mean by rearrange? Rearrange means make your left hand to be your right hand, make your right hand to be your left hand. This is an equation. So because it is an equation because of the equal sign, it is an equation because of the equal sign. So because this is an equation, whichever way you switch it, it is still correct. For example, if you have 2 plus 3 to give you 5, if you also say 5 equal to 2 plus 3, it is the same thing, whichever way. So when we rearrange, we want to make our left hand to be our right hand and our right hand to be our left hand. So left hand side to the right hand side and right hand side to the left hand side. This is now LWH is equal to V. Now we did this because we want to make sure that the width is on our left hand, like I said. the variable you're solving for, it's always good to make it to be on the left hand side. Now you notice that this means length times width times height equal to volume V. So W is not alone. You want to make it alone by itself. So that means you have to know what to do to remove length and the height. You want to cancel them. And how do you cancel these now? You can now say divide both sides by length times height. So you now have length times width times height all over length times height equal to volume all over length times height. Now when you have it this way, why do we use divide? We are using division because it is being multiplied by W. When we go to situations whereby it is added, then that would now be, we use subtraction. If it's in a situation whereby it's subtracted from, then we'll use addition. If it's in a situation whereby it is being divided by, we use multiplication. But in this case, it is being multiplied with W. So, because it's being multiplied with the weight, which is W, we now have to divide by it. So this will cross out this will cross out this, and we now have that our weight is equal to volume all over length times h. And that gives you your answer for number 1. Number 2, we have mv over t. Force is equal to mass times velocity, all of them divided by acceleration. Of course, divided by time. I'm sorry. Now, force is equal to mass times acceleration. Of course, this is the definition of force. And acceleration, of course, is velocity divided by time. But anyway, this is not what we're interested in. We are interested in solving for t. For t. We want to solve for t. So as usual, where is our t? Is on the right hand side. So let's rearrange. If we rearrange, we now have that our mv over t equal to f. Now if you look at this, I will show you 2 ways by which you can solve this. I'm going to show you 2 ways you can solve for it. The first way you can solve for it is by multiplying by the LCD. That's the first way. And what is the LCD? If you look at this denominator, is t. Actually, if you look at this denominator, it is f over 1. Because anything divided by 1 is still that thing. So if you compare the 2 denominators, the LCD is t. So you now multiply both sides by t. You multiply both sides by t so that you don't have to deal with fraction. So if you multiply both sides by t, you now have that t times mv over t equal to t times f over 1, which is still there. So this t will cross out t. And you now have that mv is equal to tf or ft, whichever one you say. mv equal to ft. So you need to rearrange again because now our t is now on the right hand side. So we need to rearrange again. You say that ft equal to mv. And then you now divide both sides. You divide both sides by f. It is always good to put all these, but because of time's sake, I will not be writing it all the time. So divide both sides by f. You now have ft over f equal to mv over f. And then f will cross out f. And then your t will be equal to mv over f. That's your t. That is one way to do this. One way. Or another way you can solve for t is when you have mv over t equal to f over 1, You may wish to take the reciprocal of both sides. Reciprocal. When you take the reciprocal of both sides, take the reciprocal of both sides. Now, what do I mean by reciprocal? Some people will say flip, flip. That's what some people will say, flip it, flip both sides. Flip, F-L-I-P, flip. But I want to use the real mathematical terms. Okay, so when we take the reciprocal of both sides, this will give us T over mv equal to 1 over f. And then when we multiply both sides by mv, when we multiply both sides now by mv, we now have mv will cross out mv, and then our t will be mv times 1 over f. So our t will be mv over f. That will now be our t, mv over f. So whichever way you want to do it, that's fine. Now, you take the reciprocal if you have a fraction, if you have fractions, and if you don't have any, if you have just one term on the left-hand side, one term on the right-hand side, and if it's a fraction, then you can take the reciprocal. Now, but if you have more than one term on the left-hand side, you don't take the reciprocal, no, you don't do it that way. The next example, number 3, perimeter to be A plus B plus C, perimeter of a triangle, and we want to solve this for B. First thing, rearrange so that the B could be on the left-hand side. A plus B plus C equal to perimeter. Now, you see in this situation, the A and C are being added to B. In the first example that we did, example 1, it was being multiplied, so you divide. In this case, it's being added. So of course, when you move this over, it will now be subtracted from. So B will just be B minus A minus C. Now, some books might do it another way. In some books, you might see it this way. But I don't usually like going this way. Minus A minus C. Then whatever you do to the left-hand side, you also do to the right-hand side. Minus A minus C. And this will cross out, this will cross out. B will now be B minus A minus C. Yeah. I don't usually like doing this way because sometimes when you have a lot of terms, you see, you keep on doing it, and there might be some errors. But look at the way I like doing it. I have to move A and C over to this side of the neighborhood. Just like the way I did linear equations. When you move A, A is on the left-hand side. What is the sign before A? Is a positive. If you move it over here, it becomes a negative A. What is the sign before C here? Is a positive. If you move it over here, it becomes a negative. And remember what I said in linear equation. Somebody who is there already should be there. Anybody coming in should be behind the person already there. P is there already. P is there on the right-hand side already. If A comes to the right-hand side, first of all, it will change its sign from positive A to negative A because it's moving over to a new neighborhood. And because of that, it will also come behind P, not before P. If C comes over from the left-hand side to the right-hand side, it will also join the trend. It will be negative and it will line up behind the last person. When you want to enter a bus and you see people lined up already, would you go and stay in front of the first person in line, or would you line up behind the last, or would you line up behind the last person? You will have to line up behind the last person. So this, or if you do it this way, that is also correct. That's fine. The next example, example 4. A area is equal to half times height, L1 plus L2. Now this is the area of a trapezoid. Trapezoid where h is the height, and then L1 and L2 is the sum, are the parallel sides of a trapezoid. The first and the second length. And then h is the perpendicular height. Okay, you want to solve this for the height, h. So as usual, let's rearrange it. It gives us half h, L1 plus L2 equal to A. So here, we still have a fraction here. This is the same thing as saying h, L1 plus L2 all over 2. It is the same thing as saying that equal to A over 1 is the same thing. And like I said, in this case, LCD, the LCD is what? 2. So you multiply 2 by everything, L1 plus L2 all over 2 equal to 2 times A. So 2 will cross out 2. I have that h, L1 plus L2 equal to 2A. And the next thing you do is to divide both sides by L1 plus L2. So you have h, L1 plus L2 divided by L1 plus L2 equal to 2A divided by L1 plus L2. Because this is seen as a multiplication, you treat it as one entity, the h and this thing, the terms in parentheses, L1 and L2 is seen as an entity. So because they're in parentheses, this means multiplication. You cross it out, and you have that your height is equal to 2A over L1 plus L2. You can use another method to do this if you want to. And what is that method called? You can flip it. If you flip it, you will still get the same answer. I bet you. You will still get the same answer. Like if you take the reciprocal. But you will need to also use the correct steps in order to get it. So you can try it. The next one, question 5. Example 5, I mean. A is equal to half h, L1 plus L2, but in this case you want to solve it for L2. So what do you have to do here? You rearrange as well. L1 plus L2 equal to A. Of course, the LCD, you find the LCD. So after doing all those things, you have that h, L1 plus L2 will give you 2A. Will give you 2A if you follow the step I've done it here. So the next thing you want to do is you can now divide both sides by h, right? L1 plus L2 divided by h, 2A all over h. So that the h will go, this will cross out. You see, I wrote this thing on another step. I know this, you see how I'm arranging the steps, one at a time. This is a different step on its own. This is a different step on its own, where you have to divide. So this is L1 plus L2 equal to 2A over h. Because some people will come and skip this step and just write this. Don't rush it now, don't rush. Do it gradually, step by step. So when you have this now, L1 is, you want to solve for L2. So L1 is not supposed to be here. Move it to join this neighborhood. This is positive here. If it comes over here, it will be negative. And it will line up behind the people already there. So L2 will be 2A over h minus L1. Some books will say subtract L1 from both sides. It's still the same thing. If you do minus L1 here, minus L1 there, yeah, some books will say that. Subtract L1 from both sides. All right, we are moving on. I want to kind of cover every single thing that you might see. I want to cover all around, but we are moving on. Number 6, S is equal to UT plus half AT squared. What equation is this? This is a Newton's third equation of motion. Well, this is an equation of motion. This is an equation of motion from Newton's laws of motion. You have about 3 of them, I think so, if they have not discovered more. But from Newton's laws of motion, this is S is the distance, U is the initial velocity, T is the time, A is the acceleration. I want to solve this for you. In this case, we have, well, the U is not squared. So if we do the next example, you will see where I'm talking about squared. But you do this one as you have been doing others. Rearrange ut plus half at squared equal to s. You want to find u, so move these guys over here. So ut will be s minus half at squared, and then you divide both sides by t. Ut divided by t, this is a step on its own. Some people will come immediately and put over t here. You're skipping steps if you're doing that. Equal to s minus half at squared divided by t. So t will cross out t. So your u is equal to s minus half at squared divided by t. Some instructors might want you to simplify more, and it's not bad if they want it. You can also write u to be 1 over t s minus half at squared. But they will still want more simplification. So you can now say that u will be equal to s over t minus half at. Whichever way anyway, but these are all correct. But whichever way, there's some instructors might just don't mind you leaving it this way, or they want you to leave it this way. Alright. The next one is number 7. C squared equal to a squared plus b squared for a. All the examples we have been doing is finding the variable but without the square. If you watch all the examples we've been doing, we've been finding the variables without the squares. But in this case, we are asked to find a, and a has the squared. So this is now quadratic exponent. Now what will you do to this? Let me deviate a bit. If you have that x squared is equal to 4, this means what number will you square to give you 4? You know it's 2. But it could also be minus 2, but we just know it's 2. But this means that x will be plus or minus square root of 4. Right? So this is x will be plus or minus 2. So anytime you have a square, if you want to find the actual value, you've got to put plus or minus. Because this could be 2, positive 2 all squared. Positive 2 all squared will give you 4. Negative 2 all squared, which is negative 2 times negative 2, will still give you 4. So when we have this kind of situation, we have to be careful about how we will find a. But we still have to follow the same procedure we have been following. We rearrange this. Rearrange it. A squared plus b squared will be c squared. Move this guy over here because he's not needed to join this neighborhood. A squared will be c squared minus b squared. And then a will now be plus or minus square root of c squared minus b squared. Just like you did x, just like you have x squared equal to 4, x will be plus or minus square root of 4. That's the same principle here. Okay, that's number 7. 3 more to go. 3 more examples to go. Now number 8. S equal to ut plus half at squared. You want to solve it for t. First of all, rearrange ut plus half at squared equal to s. Then you want to, now in this case, you have to be careful. You have your t here and t squared here. So you've got to be careful now. Recall, and that reminds me, before you view this video, please, you need to understand the quadratic equation that we have done so far. Okay? Now, recall the general form of a quadratic equation. General form of a quadratic equation. Will give you ax squared plus bx plus c equal to 0. This, like I said, first term, second term, third term. Now, if you look at this, actually, you see, it looks like the same thing. This is quite different from what we have been doing, because t is here and t is here. So this is now a quadratic equation. It is not even a linear equation now. So let's put this in this form to look like this. This will give us half at squared plus ut equal to s. Then we move this over here. Half at squared plus ut minus s equal to 0. So this looks like this, right? And then when you have this from the general formula for this, I would like you to view the video on solving quadratic equations using general formula. It will just waste time if I come and start factorizing this. It's gonna waste time, and I don't want to get you confused. I don't want to do that, to get you confused. But the general formula here is x will be negative b plus or minus square root of b squared minus 4ac all over 2a. So when you have that, that is the same way you have that is the same way you do this. Right? B is the second term, C is the third term, and A is the first term. So if you look at this now, compare. If you compare this and this, your A will be 1/2 A. Of course, your x will be t, your x is t, your x is t, your A will be 1/2 A, your B, let me write it here, x will be t if you compare this, A will be 1/2 A, B will be u, and C will be negative s. So we've got to put this right here like it is. Now, if you want a detailed solution of this, then just email me and I will show you a detailed solution of it. So x will be t. So our t, because we are asked to solve for t will be equal to negative b, negative u, plus or minus square root of u squared minus 4 times a is half a times c is negative s all over 2 times half a. So our t will be equal to negative u plus or minus square root of u squared. Now negative times negative will give you positive, plus 2 into 4 will give you 2as all over 2 will cross out, and this will give you a all over a, and that's the answer. If you want a detailed solution, I can solve this in details. I can do that, but if I start doing it now, it might get you confused. If you want a detailed solution, email me and I will do that. Okay, number 9. S is equal to 2 width times length plus 2 width times height plus 2 length times height. This is the surface area of a rectangular prism. Surface area of a rectangular prism. So in this case, you're trying to find it for length, L. So let's rearrange 2 width times length plus 2 width times height plus 2 length times height equal to S. Let's bring all the L together and move this over. 2 width times length plus 2 length times height equal to s minus 2 width times height. The length is common here. We factorize. This is 2w plus 2h equal to s minus 2wh. And then you divide both sides. You divide both sides by the 2w plus 2h all over 2w plus 2. You see I'm doing it as a different step. And this will cross out. So your length will be surface area minus 2 times width times height all over 2 times width plus 2 times height. Okay. The last question, the last one. Number 10, let's do a sample of cube 4 over 3 pi r cube. And you're told to do it for r. This is the this should be volume of a sphere, V. Volume of a sphere. 4 over 3 pi r cube, volume of a sphere. Okay, if you want to find, we've been doing squared, it's the same thing if we have cube. For instance, if you have s cubed to be a, then x will be cube root of a. And that will give you 2. If you have x4 to be 16, then x will be 4th root of 16, and x will still give you 2. So you have 4th root, 5th root, 6th root, 7th root, depending on the power that you have. So rearrange 4 over 3 pi r cube equal to v. Now what does this mean? 4 pi r cube over 3 equal to v over 1. LCD is what? 3. Multiply both sides by LCD equal to 3 times v. 3 will cross out 3, so you have 4 pi r cube equal to 3v. Then divide both sides by 4 pi. Divide both sides by 4 pi. 4 pi will cross out 4 pi. So you now have that r cube is equal to 3v over 4 pi. And of course, you take the cube root of both sides. So r will be cube root. Let me draw this very well. Cube root 3v over 4 pi. And that is the answer. Cube root. Or some textbooks might write it this way. R will be 3v over 4 pi all raised to power 1 over 3. Now, do you understand how we got this from? Because if you take the cube root of both sides, you actually have r cube times 1 over 3 equal to 3v over 4 pi times 1 over 3. So that 3 will cross out 3, and you have 3v over 4 pi 1 over 3. That is actually how we got it. It's just like saying square root. You know, when you have square root, if we have something like x squared equal to 64, and you want to find x, all you need to do is to take the square root. Taking the square root means multiplying the index by half. That is what it means. So 2 cross out 2, and x will be 64 raised to power half, and x will be square root of 64, and x will be 8. I mean, you can add plus or minus, plus or minus. How we actually got it. So I want you to also review the laws of an exponent, because that is needed here. Alright viewers, thank you so much for listening. I hope with these examples you have understood it. With these examples, if you still have questions on this, feel free to go to my website and ask your questions or make your comments on the YouTube page. For the moments of conscience today, I would like to say something important, okay? Once there is life, there is hope. I don't know who actually made that quote, but that quote is really important. If you're living, you thank God. I mean, no matter your situation, just thank God that you are still alive. I mean, there is hope that it will go well. I mean, even if you've lost your job, you've lost a loved one, you've been finding it difficult all these years, we are coming to the end of the year. Thank God for the life of this year, and we hope for a better year. We hope for a better life next year. All right, I wish you all Merry Christmas and a Happy New Year. Take care and watch out for the other segments.